Hello, everyone. Welcome to Arup. We're very pleased to have you all here and to host the Skyscraper Museum for the kind of kickoff of the in-person lecture series that I think will be really exciting. And we have a very good session coming up. My name is Michelle Roloffs. I'm an associate principal instructional engineer here at Arup. And as I'm sure you all know from deciding to come to this lecture, we're kind of going a little bit back in time to reflect on two of the really groundbreaking projects back from 2015, which unfortunately were not built, but still are very important in the kind of trajectory of mass timber. And I dug up some of the old press from the images back when this was announced in 2015, the tallwood timber competition. And it's appropriate that we're hosting this at Arup. We were involved in both projects, and I personally worked on the shop tower, the East Coast Tower. It kind of kicked off my mass timber journey. And I think is what we'll hear today, these projects, although unbuilt, really built the foundation for a lot of the work that followed. And so, that's true at Arup, all of these projects that kind of came on their heels, some, very directly inspired, some more less directly, certainly informed a lot of our kind of understanding of the various challenges with mass timber in the American context. We had been working in overseas for a while before that. And I think one of the interesting learnings when you first get into a mass timber project like the 475 West 18th Street was, for me, you really understand this interplay between a lot of different disciplines that you don't normally think about in traditional construction. So, fire, acoustic, structural, sustainability, there's this really strong connection. And it's important to kind of understand that so that you can push the boundaries and, build taller, like we'll be talking about today. We'll hear a lot more about this, but, a lot of the work that came out of these early projects included, fire testing, acoustic and vibration testing that needed to be done for us to really kind of set an understanding of how mass timber would work in, as we built larger with newer materials. Here at Arup, we also have taken some of this information and translated that into our sound lab, which some people may have been in before, or onto the Motion platform to kind of experience what it sounds like and feels like to be in some of these different spaces when you're talking about building with a new material. If anyone's interested in that, feel free to chat with me about it later. And these projects really allowed this kind of the next level. The permitting project for both Framework and 475 West 18th really informed the performance-based design approach for Ascent, which was ultimately built, and the a lot of the thoughts in some building taller led to more hybrid construction, which we'll hear more about, and some more innovation in high seismic zones, which we'll also hear more about. So I'm very excited to hear more from our speakers, and I'm going to bring up Carol, the founder, director, and curator of the Skyscraper Museum, to tell us more about tonight's programming and the exhibit.
Thank you, everybody, and thanks so much for coming tonight. I'm so pleased that we can meet here at Arup, and thank you to Michelle and everybody for the wonderful spread and the venue that's large enough to accommodate all the people who are interested in mass timber, a much larger number than we can have in the museum. Has anybody seen the show at the Skyscraper Museum yet? Oh, wonderful. Well, the rest of you need to come. We're right in Battery Park City, in the southernmost end. And we're open on Wednesday through Saturday from noon to 6. The admission is free, so everybody can come. On our website, you will see the installation views in the gallery. A show that we tried to organize, as Michelle mentions, historically, chronologically, but also thematically. And like the lecture series launched tonight, within a 6-part series that will run through July. And I'm not going to take time to give you all of the speakers, but it's a really wonderful roster. And in May, we have Michael Green from Vancouver and also Andrew Waugh from London. I'm speaking about their work. So the series is balanced between architects and engineers, and these larger thematic questions that we want to explore on the professional level, because the gallery is really set up to introduce to the general public the subject of mass timber. The view back, looking at some of the more theoretical towers back to a wall that sets up the context for the exhibitions, but also I hope the important overarching narrative that's changed in these past years that we're looking at in the decade from the winners of the competition in 2014, who are here to tell you about that and what they did in the last decade as well. And the place that it seems that the architectural and engineering community is today, which is to be principally concerned with the issue of climate crisis and embodied energy. And so one of the virtues, obviously, of mass timber is its carbon cost is extremely low, unlike steel and concrete. And it is a way that the building community can address their complicity in the overall climate crisis and carbon emissions. So, okay, great. And so everybody here, I'm sure, is familiar with all of this argument, but I just want to use these images to underscore the idea of the embodied carbon as being the principal concern of the solution of mass timber that we're going to explore in the whole series. So in tonight's program, and I'm going to very briefly introduce Thomas Robinson, who will be the first speaker, and Chris Sharples the second speaker, and also then our moderator, Jeff Spiritos, who are listed here. The project framework that Thomas will talk about, and the 475 West 18th Street were the winners of this 2014 competition. And the announcement here about 10 years ago, and you see Jeff Spiritos, our moderator, and is accepting one of the awards from government officials and Secretary Vilsack of the Department of Agriculture, and the teams arrayed below. I won't tell you about this competition because our speakers will, but it marks a very important aspect of the taking root of tall timber, mass timber in the United States, and that is actually the role of government and incentivizing. How does mass timber consolidate as an industry, which it hasn't done? How does it grow? How do we bring in the developers as well as the engineers and the architects who are concerned with these issues? So those are the larger ideas that we want to explore over the course of the series. And so just very briefly, Thomas Robinson is the founder and principal of Lever Architecture. Prior to establishing the firm, Thomas led cultural and institutional projects for Allied Works and for Herzog and de Meuron. He received his Master's of Architecture from the GSD at Harvard and his BA from the University of California at Berkeley. And many of you know our New York principal from SHOP, one of the founding principals of the Lower Manhattan-based internationally active practice. With currently Chris's concentration is on the revolutionary models of building that embrace next generation environmental and material systems, such as bio-based materials, and as well as process-driven innovation utilizing offsite manufacturing to achieve more efficient and environmentally responsive building delivery. And then I'll just mention now that Jeff Spiritos, who was the development manager for 475 West 18th Street, will be our moderator for the evening. So he is the developer and a very dedicated advocate for mass timber and evangelist in the community. And I have really Jeff to thank for almost all of the connections that helped to establish the research and the basis for both the exhibition and the series, and especially tonight. So Thomas is going to come up first and do his presentation.
First, I want to thank Carol and the Skyscraper Museum, for inviting me to participate in this panel with Chris and Jeff, and also for Arup for hosting this discussion. These are all folks that have been involved in it, and I'm really thrilled to be back in New York. And really, in the next 20 minutes, what I want to give you is sort of an introduction to Lever, a brief history of our entry, what we call framework, and really like its role as a catalyst in the conversation about tall timber in the United States, but also for us as a relatively young firm, it was really transformational to how we've been thinking about architecture since then for the last 9 years. And there's really sort of 3 areas that I wanted to hit on. One is hybrids. Framework was this pure wood project, and what we found when we went out into the market that we ended up doing a lot of buildings that were steel and timber, or concrete and timber, and even reclaimed timber. 2 is the importance of sourcing, where materials come from and the impact of the decisions you make about materials, we think is critically connected to issues around climate change, issues around equity, and also I think issues around design and architecture. And lastly, more research. So we haven't really stopped. Framework set us on sort of a path of doing research, and we've been working on different research projects, both publicly and privately funded, for the last 9 years. And I couldn't say, and we're really developing, I think, the next generation of systems that we hope everyone will steal and use. But Lever's located, it was founded in Portland, Oregon. This is Mount Hood, which, when it's clear, we can see it from our office. But the reason I start with that is, unlike New York, when I look out here, you just see buildings, you see the river slightly. In Portland, it's nature that really can sort of dominates sort of our psyches as architects, and we're really interested in the relationship between the buildings we work on and the sites we work on, and this larger material landscape. So Oregon happens to be, over 60% forest, and it actually is also the best place in the world to grow Doug fir in its native habitats. So we have, in a way, this natural advantage of this amazing kind of climate and material for trees. And this has sort of led to this evolution and innovation in timber that's been going on for quite a while. This is a cross-laminated timber panel that many of you have sort of heard of. But I think this goes deeper. Our work as a firm, is really not just about cross-laminated timber, but it's about thinking about where materials come from and how they connect to experiences. So this is a winery that we just recently finished using regionally sourced timber, and investigating working with new materials like mass plywood. This is a pavilion that was done just at the time of the exhibit. And then this is a project that was finished last month, working with Timber Lab on some of the materials and some of the technologies we developed in 2016. This is an office for a digital ad agency. And when we talked to Timber Lab, they said this was the most efficient timber building they've ever built. So we built this in 11 months. So that's the kind of things that sort of dovetail back into our office. This is Albina Yard, completed in 2016. And it was really the first building in the United States, I guess in the world, where we're using domestically sourced CLT fir in an office building. And at that time, there was only one press that was making this. This is in Southern Oregon. And we sort of took a more culinary approach to the design. So, because we realized we had to really start with the material, like a chef might start with an ingredient and then build a meal. We sort of focused on that, and we came up with this term that was really a play on farm to table, forest to frame. So that was really for this project. And you might have heard this term sort of batted around about design and architecture. And it was really about that idea that in order to do these type of innovative pieces, that sometimes you have to start with the material itself, understanding what you can do with it, how you can actually get it permitted. And these were all things that were happening as we were thinking about framework. And this is my favorite image of the project. which is the panel you see hanging in the air, was actually grown in the forest in the distance, fabricated on that press, and then shipped to Portland and put together. And you can see a video of this work if you go to the Skyscraper Museum. So framework, 2015, I think September 18th, that's actually Chris, you can see right in front of us. The developer, there's Jeff, and there's Anjali Halava, who's standing next to Jeff, who was the sort of lead developer who I still work with today. It's, of course, they have to have the award ceremony in New York because it's New York and it's on the High Lines. Not a tree in sight. But for us, it was just incredible opportunity to participate in this conversation about the future of building. And I think what's exciting for us is to sort of be part of that conversation, and framework for us was that opportunity. And I think what was framework? It was really, and Chris will talk about this too, we were trying to demonstrate with funding from the USDA, $1.5 million of funding to demonstrate that you could build a high-rise timber building. And we're really fortunate in that we basically went through 100% CDs and testing on this project. So pretty much we did everything but build the building. And that testing has become, it's publicly available, it's become sort of used by other people. And that's been really, I think, an important part of this ongoing conversation in architecture. Another really important kind of thing for us that I talked about, and this is related to sourcing and issues around equity, is this idea of a different way of thinking about building. And we created this diagram that you see here late one night before the competition was due. And what was interesting about it to us is how much of the things that you see in this diagram have actually come to pass in the last 9 years. We don't take credit for that, but it's really exciting to sort of see that evolution in such a short period of time. And from an architecture point of view, this idea of, you know, what should these buildings be as buildings? And this, you know, super tall Doug Fir, you can see the person down here to give you a sense of scale. We were thinking about, you know, we're trying to do this tall wood building, but there's these living tall wood structures that are 400, 600 years old, 260 feet tall. And the idea of these resilient timber structures, and actually that idea kind of led to this concept of saying, what can we do on the West Coast that's different from wood, that's different from steel, that's different from concrete? So we developed this, what we call a post-tension CLT rocking wall structure. These are the rocking walls here. There's 8 of them. And they'll come back later, so you'll understand what I'm talking about. But basically, think of it like a building where the force hits it and it's tension, so it can actually spring back to center. So that idea of a building you could reoccupy immediately after an earthquake. So we were really fortunate. We did like over 40 full-scale tests. I signed all the contracts with all the different labs throughout the country. We were in, you know, Pennsylvania, we were in San Antonio, we were in Portland, we were in Oregon State. So this is just a sampling of some of them. But also, to make it even more difficult for us, we had a building that was a mixed-use building. So we had a bank and retail on the ground floor, offices, and then 60 units of affordable housing on the upper floor. So you can sort of see that. And that obviously was a challenge to kind of figure out how these 8 rocking walls translated through the building and then became these housing elements. So just to sort of understand a little bit how that worked. But we also, if you go back to that image of the tree, we wanted that to be something that you could sort of see and sense. So you have these rocking walls as part of the architecture and as part of the experience that you would have every day in the building. And also the idea that the facade had a relationship to, in a way, the structure of the budding leaf on trees was something that was exciting for us. But back to the prosaic part of it is we had to do a really unusual test that, you know, this is maybe folks here are familiar with high rises. Well, in a high rise, you have to have a detail where, you know, the structure needs to work for 2 hours without the sprinklers turning on and without the fire department showing up. So this was what we tried to do here, and you can sort of see here in the structure is just create one detail we had to test, and that's what this was. We call this the framework detail. So this detail had to be, a component detail had to be tested in a furnace, fully loaded. And then we basically put it in this furnace and we light it on fire. You can kind of see right here, it's on fire. And then we load it to its, you know, to its rated capacity. and I'll just, maybe you can sort of see, this is it coming out of the press, and then they do this thing called a hose test. They spray it. So this is all like ASTM. This is how they tested concrete structures for high rise. It hadn't been done in a while, but I just wanted to show you. The other thing we did was test the connections for this rocking wall. We had to take timber, bind it together, and do this post tensioning, and then basically put the equivalent of 55 dump trucks on the top of that. It's like 500 kips to make sure that connection. At the same time, we were also doing all the internal detailing. This is the Navisworks model of all the structure in that building, showing all the different systems overlaid. So, that was a lot of work, but we learned an incredible amount. And what we found going into the other work that we've been involved is a lot of it's been hybrids. This is a North American headquarters for Adidas. It's actually in Portland, Oregon. So we did 2 buildings here you see on the right and left. I'm going to talk about the right one. And Adidas, we did a competition with Turner and Oakless A Studio, which is an interiors firm. And Adidas said, well, as long as it's on budget, you can do it in timber. And we want it done 3 months faster than a typical project. So basically this whole project, 450,000 square feet, including a 600 space parking garage, was completed in 24 months in COVID. So the way we were able to do that was to develop at least a new type of structural system where we basically kind of took the idea of a precast parking garage and developed a custom girder and this, what we call a double T CLT, to create this system that's super robust and actually just then takes the grade of the parking garage through. So we were able to build 180,000 square feet in 2 months with this system, the whole structure. So super fast, but also really, I think, authentic to Adidas brand. Everything's exposed, very, very sort of flexible system. And that project has gotten a lot of different sort of recognition. And I think you're seeing people doing whole high-rise buildings out. I think this is actually a really good model for a high-rise structure. Another project that we're just finishing up is a hybrid of timber and steel. It's actually a renovation. It's in Spring Street in Chinatown. These are some photos, some scouting photos just from the last couple of weeks. But it's basically a hybrid of a steel gravity structure brace frame and then a CLT deck with these cantilever decks. We worked on this to really think about, well, it's hard to build new things in cities. So working on like something that, what's the one thing we can do a little bit differently in LA? So that was what we focused on here. This actually has, these types of braces are used in high-rise. These are Cast Connect braces. So we worked with them. And we also, I think it's not enough to just be a timber building. It has to be, I think, related to its place more than just the timber coming from there. So we wanted to do a building where we created this vertical canyon. We worked with James Corner Field Operations, who for the High Line, to develop this amazing sort of landscape canyon. So everything is accessible from the outside. So the whole circulation system goes up through the building. So this is finished. If you're on the metro in Chinatown, it's right there, and it's for lease. So if you know somebody, but they're excited about that particular project. So sourcing. Sourcing has always sort of been embedded in how we think about design. It was in framework, and that we were absolutely committed to using regionally sourced CLT for that project. And we've kind of tried to expand that in our work. So this is the Nature Conservancy's Oregon Conservation Center. So the Nature Conservancy is the largest sort of nonprofit, almost conservation organization in the world. They have a huge amount of land in Oregon. But what we wanted to do with this building is tell a story of all the conservation they were doing with their materials by using material coming off of their land. So they were actually, when there was a storm, we were looking at using timber. And I want to talk about one story, because we don't have a huge amount of time, of, beyond CLT. And this was actually FSC certified CLT from a forest that they own, but I don't necessarily recommend that. But I think there was one of the things we worked on was using juniper. So juniper is a very hardy tree that's native to Oregon. And because of fire suppression, it's gone in a way wild throughout Eastern Oregon. And what it does, it sucks up groundwater out of the landscape, meaning that wildlife actually can't survive. And we worked with a nonprofit to look at a test case of using juniper for the facade of this building. So the idea is to create a market so that we can actually afford to cut down the trees to restore that landscape. And I think that's something that we were able to do. And actually, this building restored about 700,000 gallons of water back into that landscape each year. So we're, since that time, I wanted to talk a little bit about the Portland Museum of Art. Just to be really clear, this is in Portland, Maine, not Portland, Oregon. And it was an international competition. It was a huge lift for us. And I think we were thrilled to have the opportunity to compete globally and then with a group of folks. And we were really excited to be the winner. And this project for us really combines so many of the things that I have been talking about, really this idea of a catalyst project that can unlock using Northeast fiber. And this is happening right now. We're tracking the forest, maybe not at this project right off the bat, but a couple other projects a year ago, people were like, that's impossible. It's happening, and I'm seeing it happening where people are interested in doing this work. So we're sourcing Maine fiber, which is spruce. And I think that kind of opportunity is true. And the other thing that has been really exciting about this project for me personally is its interest in connecting to Native American culture in terms of the shape of the building, in terms of welcoming communities into the museum that haven't necessarily always feeling welcome. And I think that's been a huge part of it. And I think the material of timber is something that's very welcoming to people that maybe aren't as comfortable in other types of spaces. And that's also been a key piece of that project. And, you know, I'd love to talk more about it, but I want to actually get to the discussion. And then more research. So since the time of framework, we've been working 7+ years with all these sort of academic institutions to build this 10-story version of framework. There's no sound, but it makes a big clanking noise if there was sound. But this is basically a full-scale, test of framework at 10 stories tall on the largest outdoor shake table in the world at UC San Diego. So it's right next to Miramar. This is Top Gun in the background, if you know. But what it is, this is the Northridge quake, a huge earthquake hitting this building, and basically we walked right up it right afterwards, completely safe. So this was done with all these folks, Colorado School of Mines, Washington, and we were the architects working with them over that time period to see what we could fit on that shake table. And I think this is, the next generation of what's possible. So this idea of not only a carbon positive way of building, but a more resilient way of building, at least on the West Coast. We've done a whole nother performance-based design project for a technology client. They wanted to push the envelope of what's possible to give themselves incredible flexibility, because one of the things that was an issue with timber is it spans. So timber doesn't span as efficiently as steel. So what we did on this project is we took some of the ideas from Adidas and we created this 45-foot long cassette that's also a duct, and then tied that to a seismic timber diagrid system with precast nodes, and then basically designed and engineered and tested the whole system. So basically, this is the typical element of it. And this is sort of what it ends up looking like. So you can actually have these pieces be supplies or returns. It actually works acoustically, which was shocking to us. And it works from a daylighting point of view because it actually refracts the daylight in a really pleasant way. So we were really, excited to see that kind of opportunity materialize. And then we built 6 of these full scale in Portland, brought them to the same kind of, press that we'd used on framework, and then basically destroyed them. Because that's what we had to do for the code. So that kind of work is something that's been ongoing. And this is another test that we were recently involved with. That there's a group of folks in Portland on the REACTS consortium where we get together and we decide what test needs to happen to advance the sort of technology in mass timber. And this is the point supported CLT test that happened about 6 months ago in Oregon. So basically what it is, it's allowing and showing that you can do point supported CLT, and that is related to a project, because I need to end with a high-rise project here. This is a 276 unit point supported tower in Portland. It's through CDs, it's in permit, and we are very hopeful that it will happen very soon. Just to end, I can't think of a more exciting time to actually be in the architecture profession right now. And I think I was talking to an older friend of mine who's an architect, and he tells his students that all the time. And sometimes they're like, what are you talking about? But I believe that it's an incredibly amazing opportunity for people to really dig into these new technologies. So with that, pass it off to Chris. Thank you.
That was incredible, impressive. I couldn't help think two things. If New Jersey was a forest, where we might be, and two, when Ken Frampton's critical regionalism, how the spirit and energy of a place actually and thinking actually influences your design thinking and also creativity. But in a way, I'm sort of coming at this sort of back to the future. We've always been interested in how process really informs not only the design, but how you realize design. And in a way, it started with a lot of very small projects that happened to be involved wood. Our very first commission after 7 years of higher education was Waterfront Park with a carousel house. Explain to your parents that your first commission is a carousel house after 7 years of paying education bills is sort of a chuckle for them. But what was interesting about this whole process is how we started to think about how we communicate and manage information, especially with the people who would be building it in this case, and how a process of model-based delivery was key to that. Now, in the beginning, we weren't, things weren't as sophisticated. So we were literally building large-scale models to communicate to the contractor how to put this project together, because we had to do it with Wick's Law and we had to go with the lowest bidder. But what was interesting about this process is how that use of models really gave us a chance to not only unlock how we would go about putting the building together, but how we would start to talk and have a relationship with the build team. And at the same time, we had won this very small commission competition for PS1, Dunescape, where we modeled the whole project in the computer and literally printed the drawings, the CD drawings at full scale, and built the project literally on the drawings. So moving away from the idea of drawings as representations to the idea of drawings as the instructions for how you would go about building this project. And so what was very exciting to us, we didn't realize it at the time, is how that approach could be applied at scale. What was also beautiful about this project is the information that was used to actually build the full-scale Dunescape was the same exact information to build the model that is now in the Museum of Modern Art. So the idea is, how do you begin to model your whole office around this idea of a model-based delivery process? So then from there, we went to our next project, and we were able to apply these things to, this is a commission we did just outside of Seoul, South Korea, near Paju Book City exhibition hall, using some of the same approaches that we developed for PS1. But again, what's really beautiful is and you saw this with Thomas's work, is the nature, the materiality, and how it really does have an impact on our experiences in these kinds of spaces, especially nowadays as we deal with some huge issues with mental health. But as we move from like those two very small sort of, let's say, research-based projects to the idea of imagining if you design the whole project in the computer, and at this time doing this in Rhino, and this is before Grasshopper, so if you had to change things, you had to go in there and manually do it. But what it did is it allowed us to create a drawing set that had no plans or sections. It was literally an instruction for how you would put this together. And all the elements were modeled and then sent directly to the fabricator using SolidWorks in most cases. So at the end of the day, all the pieces came to the job site. It was basically IKEA for buildings. And so these are the kinds of things in the first 10 years of the office. We eventually, supersized this and were able to apply these principles on projects like the Barclay Center. So, but what was exciting is when the competition for the tall timber building came out, that Thomas was talking about, a lot of the thinking about how we use these industrialized processes, off-site manufacturing really clicked in because mass timber is such a great material for that kind of opportunity. Again, like with PS1, the same model that was used to build the full-scale project was the same model we were able to make for exhibition in New York. So when this came out, we didn't realize at the time how this competition would really inform this idea of how we could go to a full industrialized process with this bio-based material system. The other thing that really came out of this project, and because we didn't get to see these on this, but we did learn a lot through the process. Jeff Spiritos was the one who actually invited us into this to be a part of this competition. He came, would you be interested in doing this? And we said, hell yeah, we would love to do a mass timber project. I grew up in Chester County, Pennsylvania, right next to Lancaster County. So, I saw barn raisings with the Amish. So, the whole idea of being able to use this material in an urban fabric was something that would be very exciting to us. The thing is, and we learned a lot through this process. We learned that the brokers in New York loved the idea that this would be a mass timber project. They actually were all fighting to get the commission to market this project. But what we had to deal with first was understanding how we would begin to develop a process with the building department and eventually also the higher ups at the fire department as well. Through this whole process of the CCD1s, and Arup was very much a part of this with both on the structure and on all fire related elements for this, as Michelle said, she cut her teeth on this. And we learned when we were doing B2, the Dean Street project, the tallest modular building in North America, how important it was to open a direct contact with the DOB. And we believe that this is still important today when with our other company, Assembly OSM, is getting in early and understanding how to unlock the potential of these new material systems, but at the same time, be guided through the whole process with the people at the city level. Unfortunately, the project stopped for some political reasons, and I'm not going to go into it. But as a result of that whole process, it has opened up the door for how we begin to think about how we apply these ideas of industrialization at scale and how we start to address it when it comes to regulatory requirements. So as we move from this project, we didn't, unlike Thomas, we did not get, our next project wasn't a mass timber project, but we did win some commissions, and this is some pictures that you've already seen Carol and Thomas shared from the High Line. What's great is looking at this picture and just, Amir, who's standing right behind me, is now part of Aspect, works with Bernard, he's director of architecture. And so it's nice to see, and Adama, who's very much with us still based in Toronto, is very much involved with a lot of our mass timber work. But the idea is, it wasn't like with Thomas where we immediately started getting lots of these commissions to do projects in mass timber. This is a competition we won at Syracuse for the new National Veterans Research Center. And, you know, one of the challenges with this project was we're dealing with veterans and their families. The whole idea is Syracuse was developing this program where veterans who wanted to come back to school would also have a place on campus that was really dedicated to supporting them and their families, and also the potential of what would happen after they graduated. And one of the challenges that we were told, besides the fact that we had to deal with, you know, some of the challenges of disabilities, is also the issue of trauma and how these materials, these bio-based materials, play a big role in our mental health. And so in this case, we have a 1,000-seat auditorium in this building. We wrapped it completely in CLT. This is the interior. And actually, Scott Overall, one of the designers in shop, actually developed all the Grasshopper scripts for how we would develop this project, working with Nordique in Quebec. But this is how shop operates. It's not just doing a design, but really getting into understanding how you would realize that design, in this case, at a very intricate scale. And so how we apply that, how we share these models, how we begin to understand costing these models, meeting all the requirements, whether it's, you know, fire requirements or mechanical requirements or lighting requirements, all those elements are very much a part of our design space. And so, and again, you know, if I showed you some of our non-mass timber projects, you'd be quite familiar with how this process plays out in a lot of our other work. But the thing is we see this as a very important way in how we begin to move the whole AEC industry into this idea of how much can we pull off the job site. And when you look at this material, mass timber, it is the perfect material for an industrialized process. The idea that these pieces show up at the site and they're completely finished. Now, in case sometimes things might show up and you have to actually cut a hole, it's not too difficult. You don't have to pull out a jackhammer. But the idea is that these materials are the way you think about, when you think about manufacturing, it's part of your design thinking. It's not something that comes later. It is part of how you begin to think about the overall design. These are some of the prototypes that were produced at Nordique. But what was exciting is how suddenly using these new technologies brings out a different reading of the material, something that's been around for hundreds of years, and how the craft and using these new approaches actually creates new readings, new experiences. And this is something we think really gets back to this idea of creating a more intimate connection, a more stronger empathy with these bio-based systems. So we are just getting back into this. We have two very large projects that are now in construction. Phase one for the YouTube's expansion and San Bruno. I remember when I first met with Susan Wojcicki when she was still CEO of YouTube, she said to me, I don't want some shaped, you know, squiggly building. Basically, I don't want some iconic building. I want everybody to be at their desk and be able to see a tree. So this whole idea of being really connected to nature and then bringing that idea of nature into the building using CLT. This in the phase one is actually a hybrid system, as Thomas was describing. Phase two would be full CLT. Again, this is not a high-rise building. It's a very low commercial project, but the idea is really understanding how you immerse it into this idea of a new kind of nature within a urban fabric. And again, at the level of what I'm sort of ashamed to show these compared to what Thomas was showing. I mean, especially on that last project where the MEP system is integrated directly into it. In this case, we're just running the MEP elements between the CLT and the beam, as you could see in this. So this is the project. This is another competition. Well, this is a competition we won for Atlassian's headquarters just before COVID. And this is going to be a 39-story hybrid mass timber headquarters for Atlassian in Sydney, Australia. When it's done, it should be the tallest hybrid mass timber building in the world. And what was exciting about this project, again, and I think Thomas will mention this too, it is so important to have leaders in these companies really decide that this is something that they want to do. This is not something that just comes from below. It really comes from the top of the company. So this was something that Atlassian was very interested in doing. At the same time, it is a hybrid structure. We have a steel exoskeleton with a concrete core, but we broke it into 7 different neighborhoods or villages, and each village is supported on a concrete deck. And from that deck, you have basically this CLT CLT neighborhood that rises up. Now, before this competition, we had just finished Uber's headquarters in Mission Bay, San Francisco. And one of the key concepts for this project was the idea of creating this breathing facade that would, on a building monitoring system, would open up and naturally ventilate the interior of the vertical commons of this project. So we applied the same concept to the Atlassian headquarters. It's more like a jalousie system, but it literally naturally ventilates each neighborhood. And at each neighborhood, we stepped the CLT back so that every neighborhood had its own little sort of park. And so it's sort of this shared commons, but then behind that, you had all the office space, which could slide open and actually take advantage of some of that natural ventilation. So I think this is something that, again, this is a material system that we're very interested in, but we see it as a way of leading how our whole industry can begin to think about different ways of project delivery. And one of the things that and Thomas mentioned this, is you're talking about a much smaller population of erectors, people on the job site putting these buildings together. In some cases, Len Lease was talking about when they were doing a lot of these red roof inns, they had 11 people in the whole erection crew. And maybe 2 or 3 of them were skilled, everybody else was learning. And so the idea is how we can create more efficiency, create a quieter job site, and also because it's a manufactured product, that things show up on site and they have a certain level of precision, a certain level of craft. And you don't necessarily, rely on, representational devices to manage this process. So the idea of directed fabrication, DFMA processes become really key. And safety, as we know with a lot of the work that goes on in these cities, how critical that is. But, coming back to this whole idea of if there is a problem on the job site and you're working in a material like CLT, you can go in there and fix it relatively quickly compared to some of the other sort of high carbon solutions that we're all used to seeing. The other thing is also seeing the impact on waste. But this, I think, is the most important part. It's the part that really we all forget about, is when you build a building in a city, it usually takes 3 years on average from start to finish. And everybody who has to live near a job site has to put up with it. Whether it's the noise, it's the pollution, it's the traffic, it's the safety issues. I mean, the point that Thomas brought up, that cutting construction time, by a quarter, for example, has a huge impact, not only on the community, but also on the developer's bottom line. So this is something that should be part of the conversation when we start talking about how we bring these material systems into our cities, is how we can start to really modernize and understand this relationship, not only between how we deliver the projects, but how we have a more resilient supply chain and create an environment that is really, really sort of not only going to be a beautiful project when it's done, but through the whole process of how it's being delivered has a positive impact on our communities. So on that, thank you.
It's incredible to be here with these absolute industry leaders in mass timber, from Portland, from New York, and throughout the world. And Thomas's reach has no bounds, really, and it's incredible. Forest frame, housed in the natural materials in what's the Pacific Northwest is already about. As we talked about, it's a bit further afield right here. But this industry, it's interesting, in 10 years, how far have we come in the US really from this forward building competition to where we are right now? Is it a slow development for mass timber's uptake? Is it fast? Really, and if you look at it from a worldwide scale, Europe's been at this for 20 years, longer than we have. There's both policy and commitment to sustainability that's really setting the way for the US to move forward, and North America and the world to move forward. And the opportunities that Chris and Thomas talked about, because of the inherent characteristics of the timber products in timber buildings, really make it a structural system that is only going to grow. It's the first in over 100 years. It's proven to be deliverable for tall buildings. And we really all are in this evolution that has taken us to the way buildings are going to be built in the future. Now, folks may not really accept that for this reason and another reason, but we've got this urgency of the climate crisis. And here we are with a solution that we all just want to figure out how to embrace and make the building system of the future. So let me just thank Chris and Thomas for your leadership in the industry. I want to thank Arup really for your approach to and commitment to making this tall timber exhibit and the speaker series so critical and so meaningful to the industry's growth. So let me just start by turning it over, and I want to acknowledge one other thing. First of all, the city of New York, the state of New York, and other cities throughout the country and around the globe are really focused on the importance of low embodied carbon materials. It's a mission, it's a commitment, it's wonderful to see. It's going to get a tremendous amount of both civically generated and public sector generated projects in mass timber. And New York City is going to take the stage as a mass timber industry leader that it really has not heretofore taken, but it's about time that it is on the stage to take. So first of all, thanks to New York City for that leadership. We've been focused on operational carbon for so long. Now we're into embodied carbon. We've got to solve the climate crisis. Mass timber gives us that opportunity. Question for you, Chris and Thomas. How do we get the private sector developer community, as we talked about, to really be willing to lean in, to take the risk, to not say, I'm not used to doing it that way. I really don't want to look at a new system. Of course, institutions will do that, and very forward-thinking companies will, but how do we get the development community to do that?
Yeah, it's a really great question. I think, it's interesting, West Coast versus East Coast sort of conversation here, because, when you talk to developers here, you got to get the permit. You'll have to understand the rules. If you don't have the permit, you can't get the loans. So the thing is, there's this whole fear: how long is it going to take to get through the process of approvals? And making sure that at the same time that the developer understands the principles and standards of the systems. Because we've worked with developers that, well, this is the mixes, these are the sizes we want for these rooms, and you say those sizes actually don't work very efficiently with the nature of the material. So it really requires a developer to come in and make this a priority and actually do the homework and understand how the industry operates. I think in our case, the way we've been approaching it, and this is not just with mass timber, but the whole idea of how much offsite manufacturing can impact the time, which in our case is the real argument, not necessarily the cost. We know developers who say if you can guarantee time and cost, we're willing to pay a premium. So the challenge is, how can you guarantee those things when you may not have the buy-in of the regulators, or the brokers are saying it has to be this way? So it's really about bringing these different parties together and educating them. And so where we're seeing benefit, or developers who are really taking this on, like Heinz, for example, or Jamestown, or the company you work with on Ascent, Tim Cochran's company, Newland, is that they have put the time and energy in to understand what the nature of this material system is. They've looked into the supply chain. They've talked to the engineers and fabricators, Arup, Fastenet, Northeast, all the people out there. They're doing their homework. This is not something where you go into it casually. And I think that's something that is key, and the architects should play a big role in helping them foster those understandings.
Yeah, I think this will date me a little bit, but when I was in school, I was looking at shops work, and there started approach to saying, in order to do the work that we want to do, we need to master the art of building. We need to like put the pieces together on a very sort of deep level. And I think that in the work that we've been doing, we want to almost know more, at least in the initial phase, when we're doing something for the first time. We want to know more about building it than the contractor and then the fabricator. So we're sort of going really deep. And that's why I think when I said earlier that it's really exciting time is that there's this opportunity to redefine these new systems. When I started my practice, we're doing one of our first projects was 5/1 with a PT slab, and after a while we asked the engineer questions, how much can I cantilever? It's like, well, it's this much, that's it. Can we do a little more? No. So I think that what's amazing right now is we're sort of working with almost the kind of bones of the building, like the infrastructure, and able to actually create that if you know enough, if you can actually be kind of focused on creating value. I think that's what developers want, is they want that value, and that comes out of a certain level of mastery of the technology of working with timber, but at the same time also applying a creative mind to the code. I think architects are like, oh, I have to do the code. You need to master the code, because that's the way we're able to do a lot of these early timber buildings. We understood exactly how far we could push the code to allow us to do these. All our buildings are done with the type 3D construction. Almost all, because it allowed us to basically leave the timber exposed, and we could use the sprinklers for the 1 hour fire rating as long as we could go above 75 feet. So it was like, whenever we talked to, initially, unless we were doing the performance-based design process that we had our framework, then we knew, okay, but there's very few clients that are going to go through that type of effort. So when it was interesting, sort of like, oh yeah, we're going to build a high-rise building. I meet lots of times, like maybe 4 or 5 years ago. I'm like, really? We'll see how that works out. I think so. I think that, but I keep coming back to that, and that's why I think Chris's workshop was inspiration, was to think about the entire building process, not just the design. And then in our case, because we come from a place where, at least when we're starting out, when I started the practice in 2009. I worked with the developer. It's like, as long as it's $150 a square foot, you can do whatever you want. So it changed, and I worked at Herzog Emerald in Switzerland on museums before that. So I came. I was like, okay, well,
That's a shocker.
Yeah, that was a shocker. And then we were like, I was telling, it was a joke, like we would pick in our small office, say, let's just pick the cheapest material that doesn't make us want to throw up for every piece of the building, and then build the building out of those elements so that it felt like it was something more. And I think that even with timber buildings today, you have to have incredibly efficient systems because we're in the sort of early days of this technology to allow you to actually build them.
And because you go into so much detail to pre-plan, pre-design, coordinate, when you talk about that, if you can't say it's going to cost less, it's going to take less time, it's going to generate higher rents, it's going to generate higher value, and most developers, even if you say it, there's not enough proven history to say that, okay, I believe you. And developers are typically first to be second and want to avoid the risk. They're glad to do it the old-fashioned way. And we're not talking about a New York-centric solution here. We're talking about mass timber as a building solution throughout the country, the continent, and the world. It's somehow developers need to lean in order to be able to not get lost in all these technical things that they've got to learn in order to be able to make the commitment to it. Now, Heinz, for example, we all know back in the 2016, for example, when they started their T3 model, really said this is a building business, timber, technology, and transit. They built the whole business. They were very proprietary about that. 25 projects later, either built or key design. They've shown that that is a way forward on a commercial basis. But it's just, how do we not get lost in the detail? Because whether it's code or it's structure or it's prefabrication or it's supply chain, whatever, somehow we've got to, with your leadership, because you guys are industry leaders, and what's going on in the world, does it take policy? Does it take incentives? Does it take some sort of mandate? Like the policy that says, okay, we've got to convert to this bio-based material. It's been proven technically to work. It's better for a way of living. It's better for the folks that live there. It solves the issues of inefficiency in the business, the construction business. I'm harping on this, but how do we make that transition to get developers over the line?
I mean, I think it takes leadership, that's at a fundamental level. And we've been, you're doing this for Atlassian, which is pretty stunning, right? There's somebody, there's a leader at the top of that company that says, I want to do this, and I think with anything that is different, there's two sort of routes. There's the leadership at the top, and then there's also the folks sort of that are just tinkering with these systems that they might come up with something that's incredibly efficient. And actually, when we did framework, we saw that sort of system that is rendering from 2015 that has this simple frame and then CLT. If you look at almost every office building that's being built in the US, it's actually economical. That's the system we use because we can actually get rid of all beams. We have one connection for the entire project. We just have a series of frames, and then we have the CLT as a thin beam that spans between it. So, somebody's going to come up with a more efficient system, but I think there's like sort of bottom up and top down, like there's these, I guess lighthouse projects, like, your project in Sydney where you have a theater. And we've had that experience too, where we've had developers that are, hey, the owner of Alvine Yard was this young architect who went into design build. He actually built it himself. He got interested in mass timber and he said, I'm going to do this. And he's like, I need to hire a better architect than myself to build it. But I think that's that's my sort of answer on that.
And I would also, coming at from the city side, you say, when you say we're the whole nation's in a housing crisis, the city's in a housing crisis.
Yeah.
Is the fact that to deliver the amount of housing we're talking about, the whole city would be a construction site. So thinking about how do we deliver this, there's a great story here for city government to say, this is good for communities that are going to be around these job sites, but also the possibilities of innovation within the construction industry. The fact is, when you look at the McKinsey reports from 2017, innovation for construction is just behind hunter-gatherers, fishing and hunting. And so the point is, we want to skip up to advanced manufacturing. And here's a material system that offers that opportunity. But the interesting thing about having these CEOs who want to bring these projects to fruition is that's where the research and innovation happens. And then that trickles down to, how do we do this for workforce housing? But from the city side, it's, how do we, get the science that is out there for the last 30, 40 years to the agencies, and how we set up these test requirements, but at the same time, how we bring the community story into this, that it's really something that's going to benefit at many different levels. And then there's this the other thing that we also learned from COVID was how broken our supply chain is. It's not resilient at all. And here, when you look at this whole idea, it's the diagram you showed, that circularity between, the forests, the fabricators, the erectors, and the idea is you can go to a molecular level and understand where those fibers actually came from and how they're put together. And so the idea is, it's been proven out in the aerospace industry that digitization of the supply chain, we're talking about a 7 to 10% uptick in terms of profit margins by just digitizing their whole process. And it also brings into this whole question of also ethical sourcing. You would think with mass timber that there's no forced labor in that product, but Michael Green could tell you that 80% of the timber sourced globally is use some form of forced labor. So, thinking about how we can tackle a lot of these problems and at the same time create a much more resilient, much more environmentally sound approach that can also drive a pretty good profit margin. So,
Well,
Yeah, I just want to add, we've been really focused on working regionally, and so you have to sort of build the culture up. You're not going to run a marathon day two. We tried to say, let's design really simple buildings to put together. And now what we're finding is the fabricators and the contractors are catching up. I mean, there's a huge culture of people doing incredibly sophisticated work now in Portland. But when we started, nobody had a CNC cutter to cut panels, so they cut them with pull saws, and now it's changed. And now we're involved with, like, now it's public, we're building, we're the architects, which needs to be built to the shell, and then most of the money's inside of it, right? For like a 1,000-foot long, 220-foot wide CLT factory in Southern Oregon that's going ahead, and then there's a lab, a fire lab, the first fire lab that's been built for an American university in, 40, 50 years, that's going ahead at Oregon State. There's a new acoustic testing facility that's happening with the University of Oregon Portland that we're building. So there's all this stuff happening that will enable people to feel more comfortable about these types of products, and I think that's and it'll be tested in the United States, it'll be made in the US with these regional products. So I think that's exciting to see that happening. We're seeing it happening in Maine, we're seeing working on projects in Detroit, they're looking to source from their forests. So there's a lot happening that I think it's just to be optimistic about. And I mean, Portland's a relatively small city, you could fit all the high rises in Portland in one block in New York. So I think there's an incredible opportunity within these cities that are constrained for a product like mass timber, because stick frame, I was told today it was illegal in New York, and I'm really excited about that fact. I shouldn't say that because that means that mass timber is a much more viable kind of opportunity for housing, like the supported projects that we were showing you.
Your designs are quite beautiful and innovative. I really appreciate this presentation. I have one question though, when it comes to fire. When wood burns, it creates toxic smoke, and it's the smoke that kills people, not the fire. Steel and concrete don't do that. So how do you get around that with larger multi-story buildings?
I think it's a really good question. I think the concern, there's definitely trade-offs with materials, because I think one of the issues with like a, say, steel or concrete building is you have all the finishes that are actually covering up those materials that are as toxic sometimes as the, you know, the primary structure. But the reality is with timber, you know, one of the big issues is really making sure we don't expose more than a certain amount in a high-rise building. So that, like, for instance, on framework, we can actually on a high-rise building only expose maybe 40% of the timber. So we have to minimize it to a certain extent. On these lower buildings, like that's why it's about 75 feet, where you can actually use all of it. The, you know, the issue is that you have the ability to exit those buildings really, really quickly, right? But I think that's why I think the hybrid thing that you're seeing Chris do, where you're compartmentalizing, you know, that timber, you know, every 4 stories, which I think is brilliant. And I think that's what you're going to see, where you're going to be mixing these materials. You know, I actually think like the mix of exposed concrete with an exposed deck, like you saw for Adidas going higher. I think those are sort of the things you're going to see. Obviously, whenever you have a fire, you're going to have smoke from whatever is burning. I don't know. I'm not a scientist on smoke. And it would be great to have like David Barber, you know, talking about those things here, but I think that's, you know, those are the sort of issues that I see. So I don't know if that answers your question, but I think we're very kind of knowledgeable of, you know, when you go high, you have to definitely limit the kind of amount of wood that would be exposed.
For the point supported CLT systems in your research, how did you achieve longer spans in both directions? That CLT has stronger properties in one than the other by a significant margin.
Sometimes on those projects, there's always, you know, CLT has a strong and a weak direction, you know, so, you know, it has the strong direction spanning farther, and then in the short direction, we're spanning, you know, say 10 feet or 12 feet, you know, so basically those point supported systems really only work, you know, typically for housing, where you have a more compartmentalized model. If you're doing office, it's, you know, you probably don't want a column that's, you know, 12 feet on center in an office unless it's at the perimeter, which is where the frame works. But I think it goes back to Chris's, you know, point, you know, that you have to sort of adjust the design to the kind of current capabilities of the material. I mean, I think in 10 years, there's probably something that it does it better and is more effective. We just don't know what that is, but we do have to sort of work with the material we have.
Yeah, and I would just add one other thing on the fire thing, just to sort of go back to that. There's something also interesting in terms of the safety factor of how much additional material goes on, sort of the part that's sort of the sacrifice layer. What's interesting is once it reaches that char layer, you know, things start to extinguish. Once steel fails, it's failed, and you got to take it out. And so the possibilities of thinking about resiliency when you talk about these bio-based systems is, you know, you could scrape off the char layer and wrap it in sheetrock and, you know, go about your business. But with a lot of these more carbon-based materials, you basically have to take the building down. And that's something that also has to be considered is the idea of how long can these buildings last? Well, we've seen hundreds of years if you go to Japan and some other countries. So the idea is also thinking about life cycle when you think about these, because at the end of the day, as Jeff said, it is a carbon bank. As long as it doesn't burn or decay, it's not going to release carbon.
You talked about
material approvals, permitting. Can you talk a little bit about, I know Arup and your firms have been involved in engaging regulatory authorities. Can you talk about the relationship building that happens, engagement with policymakers and the approval processes that went along with getting mass timber to be the technology that it is today?
Yeah. It's a long process, and there's some amazing folks who are actually part of the exhibit today. An architect, Susan Jones, who's been part of code regulatory groups that are meeting to really.
And she's speaking in the series.
Yeah, she's speaking in the series, so you definitely want to listen to what she has to say, because she's put in a phenomenal amount of time really sort of talking about, what works, what doesn't. I think the biggest thing is fire, right? When people think of wood, they think of fire. So that, how fire behaves, what can be exposed, what cannot. Like, just good examples, like when, you don't want wood on the wall and on the ceiling right next to each other. You don't want too much of that, because then it feeds the fire loop between the two. So it's just like these kinds of, it's not just the material, but it's the configuration of the material and the amount that's in the building. I think those are sort of the issues around dialogue. I mean, I think we also have to remember that this is not a new material. Like, we have huge warehouses that were built out of timber that have been around for hundreds of years. But now we have more sophisticated fire suppression systems than we had at that time. So those are all the things that we're sort of working, with in terms of getting the authorities to have an understanding that, we need to meet or exceed the life safety requirements that are in the code with these buildings, or, we should not be able to.
Yeah, and I would just add, it's a behavior thing too. It's common sense. It's a collaborative process. Don't wait, until you develop it. Go and meet with them and understand what their priorities, what the issues are, going through the code. It's really about building relationships, and that's how you build trust. And you've got to look across the table and say, what are they concerned about? And it's not just the DOT, it's the fire department. It's many different people. And so the thing is, you have to embrace that. You want to walk in there and start having those conversations early on. Don't wait. Same with the community boards. You don't want the rendering to show up in the New York Times and then everybody's like, what the hell? You didn't talk to us. We're going to talk to people.
Absolutely. It's beautifully said, both of you. I want to thank Michelle so much for making this possible here at Arup's office. Thank you, Arup. And turn it over to.
I'll
Arup.
Well, I'm thanking you, Jeff, and as well as Chris and Thomas, and thanks everybody for coming tonight. I think this was a really spectacular launch of a series, which is going to ask a lot more questions. And I think it was so valuable to hear these particular architects, as well as architects in general, talk about the learning process, the design process as a learning process. And one of the things that is going to end the series is this question of optimization. Height and hybrids is the name of the last panel. How can we turn mass timber into a mass-produced product? How can we take architects as an open source, not just the lessons that you learned in the process of these 10 years of working on buildings, but to make a replicable architecture by architects that can have at scale a real impact on the climate. So there are lots of challenges, and hopefully there are lots of people here that are going to help to answer those. So thank you for coming tonight, and come back.